The topic we have chosen to present on is crystallization. Our rationale for choosing this project is because crystallization is a large industry with many different aspects and applications to it, and hence we would like to understand it better. Crystallization occurs when solid crystals are formed from a homogeneous solution. This occurs only when a solution is supersaturated. The dissolved particles in the liquid, which are randomly dispersed and do not have a set structure, starts arranging themselves in a set pattern when cooled, resulting in crystals. The two key stages in crystallization are precipitation and evaporation. Supersaturated solutions are unstable, and hence, since everything in nature tries to achieve equilibrium, the sugar molecules precipitate out to form crystals when cooled. As water evaporates, the solution becomes more saturated and sugar molecules will continue to precipitate out, creating bigger crystals.
Our first experiment was to select the best combination of sugar to make the crystals. We mixed the sugars to find out which sugar produced the most aesthetically pleasing crystal. We poured each sugar mixture into boiling water and stirred it until the solution was supersaturated. However, the experiment failed. After further research, we found out that we should have mixed the solution over a heat source instead of just putting it into boiling water, which will cool down through the process of stirring. Thus, the solution will not be supersaturated.
Learning from a mistake, we repeated and corrected the experiment, but this time boiling the solution over a flame instead. Here are the results of our experiment. We concurred that the white sugar on its own produced the best crystal and decided to carry out the rest of our experiment using white sugar. On a side note, we noted that we would have to decrease the amount of sugar used in order to produce a nicer crystal. The next experiment we did was to determine what was the best rate of cooling to produce the crystals, as we found out that different temperatures would produce different sized crystals. Once again, we supersaturated the solution and then placed the solution into either a cold or hot water bath, or left it at room temperature as the control setup. We concluded that the setup at room temperature had the nicest crystals.
For our final product, we decided to use white sugar to make our crystal. We researched on how to make the biggest crystal in the shortest amount of time and make it as aesthetically pleasing as possible. We coated the string with granulated sugar, which is an impurity. Impurities found in the sugar will expedite the rate of crystallization. The coarser the impurities, the faster the rate of crystallization.
We experimented with the ratio of sugar to water varying from 2:1, 3:1, and 4:1. Only 3:1 formed a proper crystal, 2:1 did not crystallize, and 4:1 completely crystallized. We completely dissolved 375 grams of sugar to 125 grams of water over a flame. We then added some food coloring and let the solution cool. While the solution was cooling, we dipped the string in the solution and then coated it with granulated sugar. We cooled it for 45 minutes, then suspended the string in the solution. We then left the solution on site for 4 days and monitored the changes. Here are the results.
Through this experiment, we found out that the sugar to water ratio significantly affects the results of the experiment. The best sugar to water ratio is 3:1. One of the ways that we can use this in our lives is that we can crystallize sugar on a stick and dip into coffee instead of pouring sugar into the coffee, making it much more convenient. On top of that, crystallization can be used to use up the sugar that is no longer able to be used for baking.
We needed to think out of the box to create the product.
I've learned to put whatever I've learned in the classroom into the experimental program.
I learned the importance of teamwork as we have to work hand in hand in order to bring it to fruition.